When we're talking about this, again, contention, how do we manage contention? Inside my home, I have one AP, pretty easy to deal with, right? Not a big problem there. But go into an enterprise space. Go into enterprise space where you have dozens of APs. The largest network that I ever worked on actually is still I think it's still the largest deployment in the world, is a hospitality slash gaming of 47,000 access points. That's not hyperbole. That's a real network. 47,000 access points. Now they're not all in the same one space together. They're spread across multiple buildings, but some of the buildings have as many as 3,000 or 3,500 access points in a single building. And again, break it down into areas and zones, right? Some zones are not contentious zones. Some zones have a lot of APs, a lot of users, a lot of high density. And so now you've some zones have a big problem with contention. So how are we managing contention when we have multiple access points in the same geographic area connecting to their clients and trying to optimize those clients? How does 11AX help in that situation?
Well, they kind of take a hint from other wireless protocols where they come up with color codes. So if I have a color code, I can have individuals on the same channel. And if I'm at a client where I'm at an edge where I can hear both of them, if it's not my associated color code, I don't care that that's transmitting. I can still transmit. So I mean, this color coding allows for reuse of the same frequency for clients and for allowing them to be subscribed to their particular AP, as opposed to where we used to, there was, if a client heard a beacon or a transmit on the same channel that it was listening on, and even though it was a distant AP, it still had to go quiet. So this color code scheme really helped with being able to make those cells more efficient, of where this AP cell is talking to these clients and this AP cell is just talking to these clients, just by using that color code and that frequency reuse.
So, all right, so you have to explain color to me. I'm not colorblind. But do you mean, like, you know, are they red, green, blue? What do you mean by color?
Color is just a number, and they call it a color code, but it's basically just a number that's associated with a particular AP. So whenever that beacon is, that number code is in there, and so that way it knows that, hey, that's we call it a color code, but it's not red, green, blue, right? Because I mean, at the end of the day, you know, clients and APs, you know, they are colorblind. They don't really see colors. They see ones and zeros. So we get this down into a number.
Okay. All right. So color is just more like a metaphor. Helps us lowly humans understand what the APs and the clients are doing. All right. Good. So they have this ID, this identifier. We're calling it a color that says that this client belongs to this AP, and let these two guys talk, even though they can see another one over there in the same geographic area. They can ignore him. Cool.
Exactly.
All right. Excellent. Good. So this is good. A good introduction for a couple of the things. We just talked about a few things, only a couple of things here, but this is nice, talking about 11AX and what its advantages are. And we clearly identify that these advantages with 11AX deal with the idea of dealing with increased contention, higher density devices, and being able to manage it better. Now, the nice thing about that, as we're talking about it, is for people that read the IEEE standards, you may have seen the term high efficiency, and it's actually right in the title. High efficiency is in the title for 802.11ax. So it was a goal of making this technology deal with contention in an efficient manner and make better use of the spectrum from day one, built into the standard.